Welcome back to the Rollup High Roller community. As always, nothing on the Rollup is to be construed as financial advice. We are just some educators in the DeFi space. Toss us a quick like, give us a share, a repost, send it to a friend who may want to watch this, and finally, give us a sub or a follow. It means the world to help support credibly neutral educational content in DeFi. We're here to educate, empower, and enrich you, and let's jump in. What's up, guys? Welcome back to the Modular Rollup. We're here with Carsten from Cartesi, the technical guy behind your stops, your stop losses, because you're not exposed long enough to the modular blockchain revolution. Carsten, what's going on, man? Welcome to the Rollup. We have some fun. We talk technical concepts. And yeah, we're here to learn more about Cartesi VM and your view on the modular blockchain experiment that is ongoing. So, GM, sir.
Yeah, nice to be here. Yeah, I definitely think that we're in for kind of like a very, it's an interesting future when it comes to what we constitute as blockchains, or rollups, or virtual machines and other things, because I think that in even 1 year, this space is going to be completely unrecognizable. I mean, we have some kind of like understanding that, let's say that rollups would end up being kind of like the shape it look like, but as things like icon layer and good data availability comes in, and let's say fast finalizing data availability and big amount of data can push through those things. I mean, it's the craziest thing that you can do. It's almost having your own little, let's say, cloud infrastructure. And I think that it's going to be completely crazy what we'll be able to do.
I think when people think of blockchains, they still tend to think of monolithic architectures. So could you explain kind of like why that's maybe no longer relevant and why it might look unrecognizable to that model, in the near future?
Yeah, so one of the things we have here in Europe is this kind of like let's say low cost airline called Ryanair, right? And they kind of become famous on unbundling pretty much everything, including kind of like randomly seeding people and stuff. And this is essentially what's happening to blockchains nowadays, right? Because it used to be such that blockchains were the only ones who were kind of able to do this completely, let's say, immutable history of things, of events, or a timeline. It used to be only blockchain environments that could do things like sequencing. It used to be only blockchains that could do data availability, but now these things are starting to be like, let's say, many different products in practice, like things like sequencing and history is something that a data availability layer or a sequencing layer could take care of. Like, for example, with Expresso, they provide, let's say, data availability up to some point, but not permanently. While, let's say, the Ethereum blockchain is still talking about, let's say, things like state friend and kind of like maintaining this whole history of things. And data availability becomes not necessarily something that you need to carry around all the time on your node. And this whole splitting up, including alternative VMs, which is of course what Cartesi is doing, completely changes the way that we build applications for these things, because we are no longer tied to the insane things that people came up with in the EVM or restrictions and so on. We can sit down and use regular instruction sets, regular compilers, and not pretend that, and actually not pretend or ignore the fact that the last 60 years of computing has existed.
Yeah, that's the anti-EVM thesis. What's the thesis as to why EVM wins versus alternative VMs?
I think that it's going to be blurry for quite a long time, to be honest, because I think that we're seeing with things like even with Arbitrum stylers or the massive waiting explosion of icon layer based coprocessors, it will start blending in with each other, right? I mean, back in the day, People were looking at, like, let's say, projects like 𝗵𝗶𝗴𝗵 and so on to kind of like allow us to kind of like offload in a nice EVM outsourceable way of computation and so on, right? But that pattern kind of like went away again, which is kind of like a little bit annoying because like off-chain computation is what everybody pretty much needs, right? But I think that everything basically started blending into each other also with projects like with Zero, like, because things like, and I think this is happening at the moment, where things like the stack to SNARK, as in you can take the big 200 kilobyte proof, convert it down into a small SNARK proof instead, and the recursion and so on is that it's good enough that we don't need to care about all the completely insane design choices the EVM has anymore, right? Like, we can actually start people developing applications that actually do things on chain without touching the EVM, except for proving a ZK proof, right? And that completely changes around kind of like the ability for us to connect things in ways that doesn't look like we are trying to jump through 5 different hoops of fire at the same time.
Yep. So you think this all just kind of comes together from the experience of, like, I guess, the user, but also just builders as well. That's one of the key things that Cartesi allows us, like this onboarding of dApps, of builders, which I think he further emphasizes the alternative VM bull case, which we're starting to really build here at the Rollup. It's like, well, the EVM bull case was from 2015, 2016 until 2020, 2021. 2021 DeFi realm, followed by the 2022 hacks, 2023 re-entry attacks, this, that, and the other. That has just kind of formed the alternative VM bull case, which I'm excited about. So let's dive into kind of Cartesi's design with some of the recent integrations and kind of announcements. Let's start with Expresso. How can Cartesi rollups utilize Expresso's shared sequencing layer? How is that going to build a better ecosystem for Cartesi rollups and further, establish the alternative VM or Cartesi bull case?
Yeah, so the first thing you need to kind of like ask yourself is, okay, if we are going to have 1 billion app chains or app specific rollups, or when somebody finds a proper name for these things, let me know. But like, the question basically becomes like how do we actually do this, right? And the first thing that kind of like comes to mind is that well, Web3 UX sucks today, right? That's the first thing. Part of it is because basically that there's very, let's say, very slow confirmation of actions and so on. While it's something like Expresso, you can literally get a confirmation that your particular transaction has been included within 1 or 2 seconds. I mean, it's basically the arbitrum experience, right? That we kind of get that stuff confirmed quite quickly. Second, if we are to scale to, let's say, a little bit like with cable TV, right? Like, we need almost as big bandwidth as a cable TV network, which is like something where we need this extreme performance that something like Expresso provides, right? It basically assigns, let's say, makes 30 megabyte size blocks and actually does it with, let's say, a very large amount of nodes even, and it's the ideal place to kind of like start rolling things out easily. Also because they have a focus on this whole, let's say, block builders and let's say proposal builder separation, where we can start thinking about what goes into the blocks and the confirmations of them and all the mechanics around it, which is something I don't see in other data available players necessarily. So what we've been doing in Cartesi is experimenting with, okay, so how quickly can I roll out a functioning app chain? And the answer is somewhere below, let's say, 3 minutes, right? I mean, if I want to start, like, I declare by populating a little bit like this block that this app chain exists, which sequencer is it, which sequence of block height is it, and then basically from that point on, like, theoretically anybody can compute the same application, right? And get the same state. So technically speaking, it exists in a particular state, and they kind of like, you can just submit, in this particular case, transactions into the sequencer, and they kind of like get included. then other people can compute the bridges, etc., etc., etc. And that, I mean, that's the user experience that has to exist. It has to be just as easy as, or even easier than creating and let's say a Twitter account or something like that for rollups. And on top of that, it's something where these app chains, and I'm probably not using the right term, but app chains should be something where you're in control about what vendor it's let's say working with, right? I should be able to kind of go out and get on the market and decide which provider is, let's say, providing services for me. It might even be a network, like with things like witness chain, which coming with, for example, things like 𝗍𝗂𝗍. And how do I kind of get the best quality of service for my app chain and the services that's going on with here, right? And this is kind of like why we've been playing around with Expresso. And the nice thing about Expresso and kind of like these sequencing layers in particular is that they have a quite nice API, right? It's basically listen to the incoming blocks. Is there anything distant for me or my, let's say, my virtual machine in this particular case, which is my app chain? What is in the transactions? I process them, and I move on to the next block until there's something for me again, right? So integrating these different things, because of the fact that there's this abstraction sequence, really helps in designing with things like Ethereum. You need to all consider things like reorgs and so on, and that you can kind of like end up with this nice little, let's say, nice little architecture to some extent, like our node for doing this stuff, which is, let's say, quite fully featured in this particular point, like, let's say, less than 3,000 lines of Rust. So it's something that really changes around and makes the architecture cleaner for building these things. Of course, where it changes, let's say, a bit up in difficulties is convincing the poor aging EVM what the computation state of a particular app chain rollup is, because now suddenly you move from the problem of having one app chain, a rollup that you want to settle into Ethereum, to that you want to settle a billion app chains into Ethereum, and it becomes a much more complex problem.
Yeah, I mean, Expresso can kind of bring those together, right? And bring near atomic composability. I've been trying to hit home on this point of like difference between atomic inclusion and atomic execution when it comes to using shared sequencing, something to get into. But I think generally, when you are able to deploy an app chain in 3 minutes, then connect it to the shared security and sequencing layer of the rest, socialize the costs, and also potentially share the liquidity. Not exactly sure how you see that playing out. Would be curious on how that would work.
So I get it. So
that's like robust.
I think that of course there's kind of like, let's say, the ability to kind of build a block in a composable way, right? Like kind of like you make promises between them, but also very interestingly that you can also logically say that I mean, on the same shared sequence, I can theoretically read, let's say, the state of the previous block of an app chain, right, as well. Like, let's say that, let's say, for example, I have, let's say it's a Uniswap app chain, right? I can read the state of Uniswap in the block just before it, because technically speaking, anybody can evaluate that. The moment it actually settles into something like Ethereum, for example, that's when you actually need to kind of like compute it and kind of like in an organized manner. But theoretically speaking, the state only exists at that point. I think that when it comes to block building and atomic inclusion and those kind of things, I mean, we haven't seen completely the end result here of, let's say, what can actually be possible, because it hasn't become easy for people to experiment with it, right? But if you start combining these into, let's say, things where that people can trivially write something up in, let's say, the existing programming languages, they can easily, let's say, get it working with and deploy it and actually start playing around with, let's say, the architecture of building blocks that are kind of worrying about kind of like the weird things about that's going on its VM. Then I think that basically the amount of things that are possible to do with this stuff is gonna explode, and I mean, it's gonna be completely unimaginable. Yeah, we're talking about the expressibility of, let's say, being able to do more things with, let's say, atomic sequencing and inclusion of whatever those weird terms are exactly. Because right now it's really difficult for me, for people to kind of reason about how does this work like for an EVM. But if you say that, well, this is basically a bunch of Linux virtual machines that are working in, let's say, on the same clock, which is the blocks coming in essentially, then suddenly you can start thinking more about, like, let's say, the promises that are made and synchronization between them, and it starts looking a lot more like, let's say, optimizing a workload in, let's say, a cloud installation essentially.
Yeah. And so is that like Cartesi's mission is kind of making this developer friendly, accessible tool to launch chains, to provide that infrastructure for rollups based on Cartesi rollups. Is part of this to kind of also figure out like how the best way to get around these certain trade-offs are with code processors, with shared sequencing. There's these trade-offs that we're starting to notice that modular blockchains are trying to kind of break this original trilemma of blockchains, of monolithic chains. I'm curious how like eigenlayer, integration, Expresso, Celestia, how you're kind of putting these pieces together for the Cartesi stack to kind of build the best stack.
Yeah, so of course it helps that we have the Cartesi machine, which is, let's say, the emulator, a virtual machine, depending on who you ask. That is, let's say, it's not something new. It's not like we are inventing some kind of new VM or anything. It's not like we are inventing a new instruction set. It's something that actually works. It works today. You can run Ubuntu on it. You can run Doom on it. And honestly speaking, if you have an altVM and you can't run Doom on your altVM, I don't consider you an altVM because it's not general purpose enough. But how all this connects together basically comes down to, in the end of the day, a rollup is essentially a compute primitive being executed multiple times over a series of inputs, right? I mean, that's what calculates the state. And how we understand and, let's say, get to the understanding or confidence that app chain is in a particular state is something that, with very high probability, I mean, you get quite close. I mean, some people believe that whatever, let's say, 𝗵𝗶𝗴𝗵 is telling them today, right, like MetaMask, is the truth, right? Or is the scam. And what you can do beyond that is like things like, for example, you can stick it into, let's say, an AWS Nitro enclave, then you trust AWS, right? Or you can go out and get a sampling of co-processor computations over the state, basically saying that, okay, so I know the truth is that let's say, the Expresso chain is in this state. What's, let's say, the calculated state of my app chain, which is then I go out and get a sampling using, let's say, co-processor eigenlayer, and then I get an even more kind of like higher confidence what is actually true. And then if you need like the strong confirmation, this is when you can settle to things like Ethereum, for example. But I think there's many use cases where you don't need the strongest, let's say, confirmation. And I think also when it comes to kind of layer two, let's say, rollup to rollup communication, you need more like highly probability kind of like things that this is good enough, right? In terms of kind of like bridging data or information or messages and so on around. So I think that at the same time, we haven't seen the end of all these different sequences or data availability methods and so on. So getting something where you can quickly switch between and play with them is quite important.
So how does Cartesi position in this data availability wars? Are you pro non-Ethereum DA, pre EIP 4844, post EIP? Is there going to be a change in your mind? Like, how does Cartesi give the developers and the users of this experience? How do you position?
So my belief is that it's not my belief to make, and it's not my choice to make for people, right? As in, if they want to pick if they want to pick a different religion, they're more than welcome to, and this is how you do it with our software. And that's why we're kind of like we are basically trying to make it work with everything, because at the end of the day, it really comes down to what is this little, I mean, in Cosmos, I think that people call these kind of like app chains like community computer, right? And that's, I mean, even Arbitrum today is theoretically, let's say, a governed community computer to some extent, that they choose what becomes, let's say, the evaluation of their chain. And I think that as people are kind of deploying and things become more and more autonomous, there will be different trade-offs, there will be different benefits. But I also think that when we start looking at things like, let's say, atomic conclusion, those kind of sequencing, etc., the lines begin to blur because some things will need to be more safe versus others, right? And
yeah, I thought it's use case dependent. It's like if you have a highly financialized large TVL, for example, or large stake, you may as well just do everything without extra trust assumptions. But like if you're running some like consumer application or like, you know, insert your gain here, right? It's like, well, why not optimize for the best user experience and the best cost and the cheapest fees and all that? But that's kind of the beauty of this, no? Like, with, you know, you can insert the Cartesi virtual machine amongst a different stack of other kind of pieces, and you can almost customize it like a menu at a restaurant or something, right? Like a buffet.
Exactly.
Yeah.
And that's also the thing, like and like newest designs, like the current state of the app chain defines where does it get the next block from, where they're going to get the next transactions from. I mean, why shouldn't we be able to kind of like, let's say, move between Celestia and Expresso in terms of kind of like where we get our inputs from, right? It's a little bit like switching a cable over from one provider to another, right? And I think that as we are getting, let's say, further and further ahead, we start seeing these things, let's say, between, let's say, roll-up actually VMs, as more like network interfaces versus, let's say, on message buses versus, let's say, evaluating the state of another blockchain, right? I mean, there's no reason today why in a Cartesian virtual machine we couldn't literally send ping packages between the different machines or maybe HTTP if you really wanted to, right? And that's kind of like the thing that I think that we sometimes forget a little bit with the Ethereum virtual machine. Like, I actually like the World Computer thing, except that well, this was World Computer 1.0, and I think we can make a World Computer 2.0.
I would expect nothing less from the tech mind behind an alternative VM, sir. I appreciate the idea of this composability and the different type of framework thought, rather than like, oh, this is one thing, this is separate. We need to derive consensus or data from one part. No, we can kind of bring this all together. Similarly, am I wrong to think that basically Cartesi VM can integrate with any RAS provider, any data availability layer, any interop solution? It's very much a one-size-fit-all in terms of being able to interop with everything that's currently part of this like modular blockchain kind of thesis narrative. Like, there's no reason why you guys have any technological obstacles to integrate with everybody.
I think that there's the technological, like, let's say, yes, it's a Linux machine, you could run in different ways, but of course you need to be able to kind of like reliably be able to prove that to other machines, right? So, for example, obviously, let's say some, let's say, eigenlayer data availability thing that goes out and uses restakes operators to make data available like Expresso. It's much easier to, let's say, understand the data availability chains and let's say network state, because it is tied and anchored into Ethereum, right? And that's also my preference a little bit, that there are certain kind of models out there that doesn't work very well with just like, let's say, this kind of like almost fisherman-like style of data availability where, let's say, you have to go out and get a proof that some data is published somewhere or something like that. It doesn't work in a nice structured way. Or let's say that things are hosted on a completely separate or not, let's say, security-derived network from Ethereum. And I mean, I like Ethereum for, let's say, security and so on, but some people might, let's say, want to have kind of like their particular app chains, let's say, with data available from things like Solana. It might actually make sense for them. But in terms of composability across networks, I mean, it starts more looking more like instant insurance agreements and so on instead.
Very interesting. Okay, so what is the this might be not exactly the right question for you, but I'm curious, like how do we get to 1,000 Cartesi rollups? Like, what does that look like?
I think that basically it has to become just as easy as it is right now to upload something like to the cell or to Hulk or something like that. Like from point of view of, let's say, ease, it needs to be just like deploying a Docker container somewhere. And I think that's sometimes a little bit what people are misunderstanding with things like WebAssembly and so on. Like they read that, let's say that WebAssembly is how if WebAssembly had existed, we wouldn't need Docker and so on. But I think people tend to forget that the difference between something like the Intel processors and ARM processors and RISC-V processors and WebAssembly is just as big distance as between those processors and the EVM. Like, it's a completely alien technology. Of course, there's things that kind of like general computation and so on, but like there's a lot of things that basically doesn't compile very well to it. And I think that, I mean, it took us with WebAssembly, it took it like almost 5 to 7 years for something like Python to actually run in a WebAssembly. So it's something where, like, let's say, ease doesn't come from providing, let's say, a WebAssembly base for things alone. I think simplicity comes from the fact that we can have these deterministic RISC-V Linux running machines that actually act like we expect computers to act, right? And they need to be complete, like, sized in all sorts of different ways. Like let's say, on most WebAssembly setups, like you can't go above 2 or 4 gigabytes of RAM. While with ours, we can theoretically have 64 bits worth of RAM, right? Like in terms of gigabytes and so on, right? So that's the level of ease we need to get to, and it needs to be not alien to people, because like in one of the presentations, there's this SMPC comic thing where basically like people talk about this new alien computer and so on, and the difference between a computer scientist, like we have much to learn from this alien computer, and then they GS up say, boom, I got Doom running on it, right? And I don't want a completely alien computer for people. It needs to be something where people can use it, they can reason about it, they can treat it just like something that they're expected to actually work.
Yep. Interesting. So from the dev side, it's like it's like a combination of education as well as ease of use, just improvement in the innovation side. As you're kind of coming to wrap up here, I'm curious about just your broader vision outside of Cartesi. What does 2024 have in store for us for the growth of modular blockchains? What are you seeing? What are some of your predictions or thoughts, bull case, bear cases, and where do you see this heading with the advent of RAS providers, new GA layers, new VMs launching, tokens launching? How does this what are some second and third order consequences or at least effects that maybe we're not seeing right now, but that are going to come as a result of these kind of multiple different rollups launching with different infra stacks, whether it be interop or different kind of things that you're seeing happen? I'm just curious, like, what are some predictions that you may have?
So, one thing that's for sure clear is that with things like eigenlayer, we don't any longer need to limit ourselves to the, let's say innovation on Ethereum becomes permissionless in terms of, let's say, getting just a strong economic security. And I think that will both, let's say, in the bear case, in this particular case, I mean, we're definitely going to see a few failed rocket launches. But at the same time, it might be there will be a couple of these rockets that actually make it to Mars. I think that people will be, like, let's say, there's a more feeling of more pragmatism in terms of kind of like adaptability, because, like, I mean, I've been around since 2015, 2014 something, and I mean, I remember when we were going to change the world, right? And I think we still need to, let's say, actually get there. and do something where everybody can actually start using it in a decent, let's say, coherent way. And let's say maybe kind of like as the last kind of like prediction is, I think we're going to start seeing actual verifiable computing on Bitcoin. And I think that's going to, let's say, change around also, let's say, how we think about verifiable computing, like things like 𝗵𝗶𝗴𝗵 and so on. And I think it's not completely unrealistic in the next 3 months that we're going to see things like Boom on Bitcoin.
Bold prediction. Very cool. You know, Andy says something a few videos ago, a while back on our channel, and it was about like, you know, there's all these alternative VMs coming for the EVM, but it's like, is there any settlement layer that could potentially kind of dethrone the Ethereum consensus layer, the settlement layer? And it seems like the only one that out there is potentially Bitcoin because of the cost of corruption is so high. So
what are you thinking about that? Yeah. So the main problem with is that, yes, we'll be able to see off-chain computation because of things like 𝗵𝗶𝗴𝗵 on Bitcoin and so on. But I think that, let's say, the evolution of that takes time. And at that particular point, I think that the evolution of things based on things like EigenLayer and Ethereum security, we're coming to the quality point where you need to be a little extremist to go for Bitcoin in this particular case. But I think that Ethereum has in the seeds of itself and the switch to proof of stake, it has the nature in it, just like phone lines did, right? That we started running things on phone lines to kind of create this infrastructure inversion that what we're actually using, or what actually is kind of like when we consider the Ethereum blockchain, is basically like, let's say, an inversed setup on top of something like a EigenLayer kind of like setup. So I'm not sure how it's exactly going to end up, but I am thinking a little bit that we'll get to a point where basically we don't care because we actually have use cases running on things. And this is kind of like the stuff that some of us are experts in. And well, it's probably going to be very lucrative to be experts in kind of like those lower layers. But in the end of the day, the whole thing becomes commoditized.
Right, that's something that we've been thinking about, as well as the race to the bottom at the DA layer amongst the other ones. That'll be interesting, especially at the RAS layer too. It's going to just be like the era of abundant block space is here. So it completely becomes a commodity, which is quite interesting. Carson, I just want to say thank you for coming on. Just kind of some closing thoughts. I'm going to wrap up here, and yeah, man, thank you.
No worries.
Thanks, Carson.